Hi, so we are Elisa, Giulia, and Luigi, who is not here with us today. And yeah, our project is the Atmospheric Composition Dataset Explorer, or for short, Atmospheric Explorer. And we have a lot of mentors that we thank very much for the support. Why?
Sorry, Lisa, I think we are not able to see your screen. I think it's all dark. Can you please try to share?
Oh, okay, yes, I can try again.
Yes.
Is this fine now?
Yes.
Okay, perfect, thanks. And so the motivation of this project, of this challenge, which was challenge 11, is to create an application, an interactive applications for users to interact with some data sets and create atmospheric composition diagnostic plots on demand. The problem behind this, let's say, the motivation behind the challenge is that there are these huge data sets that both researchers at ECMWF and other end users would like to be able to explore and understand more better and quicker. And also to make it easier to prototype new data products and understand how this data is behaving, get insights about the data quality, and so on. And also, of course, to create quickly plots also for research papers and any other users. So the goal is also to have a very flexible tool that can be used by these different end users. And flexible is also in the sense that it should be quickly adaptable to other data sets in the future to, as I said, explore new data sets and have all the same functionality also for other data sets. And the problem is that these data have a high volume and complexity. All these data sets are a bit different among them. So it's not easy to generalize these functions. So that's what we are trying to do. This project builds upon last year's Wildfire Emission Explorer, which was another challenge from, last year it was not called Code for Earth, but ECMWF. And the Wildfire Emission Explorer was working with these wildfire emission datasets. And the idea now we want to extend this idea to other datasets, and mainly these two datasets, the global greenhouse gas fluxes dataset and the atmospheric composition reanalysis. So they are different, and the data access method and the format are different, but we would like to have a final interface like there was for this Wildfire Emission Explorer, where you can select the country, the data type, the time period, and the reference period, and finally produce some plots. And now I'm leaving the floor to Giulia, that is also here, and we'll talk a bit about the data sets that we're using and the plots, some plots that we have produced so far.
Yeah, thank you, Lisa. So starting from the proposal of the challenge 11, we have started with some plots proposed in the challenge itself. And among all the plots, we choose to show now two plots, one for each data set considered. So this one is the first plot proposed, is a time series plot, one for each countries. This comes from the inverse optimized datasets. This dataset is scientific interesting because provides mainly free gases in terms of concentration, mean column, and fluxes. And in this plot, we are focusing on fluxes. So here, considering the CO2, so yes, yeah, I can move on, Elisa. Okay, thank you. Considering the CO2 fluxes from this data set, it's possible even to choose which kind of source these fluxes came from. So here we choose anthropogenic, so fossils flux, but the users can choose a different kind of flux. So for example, agricultural sources or natural sources, biological, etc. And with the blue line, we represent the air samples measurement, and with the orange one, the satellite measures. With the gross line is represented the spatial average. In this sense, for each country, there is a spatial average, and the area around the gross line represents the confidence interval equal to 95%. In this sense, it is possible to keep in account the spatial variability for each country. So this is may helpful for scientific or any kind of user to have an immediate evaluation of trends for different origins of gas fluxes, and also from different countries for different sources, and also with different kind of measurement. The other plots we've considered instead is from the other data set, that is the atmospheric composition reanalysis. We choose to present here the ozone mean column, total column, and it's quite representative and also important in terms of scientific consultation, also for mainly referring to the stratospheric ozone, so related to the variation during time after the CFC pollutants, and also referring to this particular stratospheric circulations and transport. So mainly here is reported an hovmoeller plots. So for on the y-axis, we have the latitude, and on the x-axis, the time. We have chosen like time step, month, but users can choose any time of time step, so daily, weekly, monthly, or yearly. And for each time steps, there is for each latitude an average value of ozone for that latitude. So it's averaged on longitude value. So this to reach these plots that starts from the other data sets, it was necessary to make some operations on it, starting from the conversion to a more common and intelligible unit. So we converted the original dataset unit of concentrations to DU that is used for scientific use. And we also have to do some cartographic operation, like shifting the longitude that is its original expressed from 0 to 360 degree to minus 180 plus 180 degrees. And here is presented as the discretized color bar, so with from the minimum to maximum concentrations. And all these plots are made from basic from Jupyter Notebook, and then it is improved as API. And so now Elisa can deepen these aspects.
Yes, thanks, Julia. So as Julia said, we have produced these plots with Jupyter notebooks that test the APIs, but our core goal is not to have Jupyter notebooks, but a Python library with these interfaces. And that is modular and can also be used in the future, as I said, for other data sets and other plot types, for example. So this is a very raw screenshot of the structure of our files so far. And yeah, there is also a new file. But basically, we have divided the architecture in 3 layers that follow an ETL pattern in some way. So we extract the data or download it from the datasets through CDS API. then we transform it. And for example, what Julia said are some transformations that we need to do to the data. And then we load it into plots, for example, so because our end goal is to have plots. And we are using also some software best practicing, like trying to test as much of the code as we can with PyTest and adding documentation and block strings. And we are creating it as a Python package that can be easy to install and use it in other environments. This is the link to our repository if you want to check it out. Although I'm not sure it's public yet. I have just thought about it, but we can make it public if it's not. And finally, I also want to mention that we have thought about using EarthKit, which is a library developed by researchers at ECMWF, because some of these functions can also be, well, already exist in EarthKit. And that is one step that we have in mind. We first wanted to try it out with very raw functions, but of course, we hope to have the time to try it out, also to use it in these APIs that will make it a bit more stratified in some way. And also something else we want to improve for next steps is the caching, because right now we are downloading all the data, not every time really, but not in a very optimized way. So these are 2 points of improvement that we have in mind. We have also started creating a UI application with Streamlit, which is different from last year's Wildfire Mission Explorer that was made with Voila, but we wanted to try it out Streamlit. So now I see if the video works. I'm not making it full screen because I'm afraid of what might happen, but I hope you can see it. So this is our first draft of the application that uses the APIs, which can also be accessed with CLI and with other Python plots. But the idea is to have this very easy interactive interface from which the user can select, as I said, a country or an area, then a time period, and it takes some time, but then you can choose the plots that it creates. And yeah, let's see how long it takes. It shouldn't be long now. Yeah, and then the plots are made with Plotly, which makes them a bit more interactive. You can zoom in and see the data by hovering the mouse on it. So that's the main next step, finishing this interface. And okay, not again, we have finished. So thanks. And we are looking forward to any questions.
Thanks a lot, Elisa and Julia, for a very interesting presentation. And I already, the perspective you provide with the last of the video. Very good. So there's a comment from Miha. He loves the Streamlit example. Grazie. So are there any questions from the audience to Elisa or Julia? So if so, please post it in the Q&A part. Yeah, again, same question as Speranza had for IU. What was your biggest challenge so far? Where you say, okay, that was something you did not expect, or something, what was that? Or did everything work smoothly? That could be also the case.
No, that's never the case. Let's be honest.
That's for be honest.
I think I can answer, although if Julia wants also to add something, she's welcome. For me, one of the biggest challenges was that these data sets are so different one from the other, And so generalizing them, which is the core of the challenge, is really hard. Even just understanding how to access the data exactly and to have the same APIs that apply to different data sets is surely still a work in progress. And even to think we have to make it as general as possible, even for the future, is something that's always on our mind. And yeah, it can be hard for many different data sets.
Yeah. Okay, thank you very much.